Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Summit Academy. In this video, working on the unit number 5 still, and lesson number 5, still talking about our functions, and now we're going to be working with tables, graphs, and equations, and being able to switch in between those. So for this first part, I want you to think, pair, share. And what that means is I want you to pick one of these graphs, A, B, C, or D, and you want to say which graph doesn't belong. So it says to write a sentence that explains what is different from the other graphs. So pick one and say why it is different from the other. So make sure you can pause, work with your partner, think, pair, and share. All right, after that, it says time and temperature. It says the graph shows the temperature between noon and midnight in one day in a certain city. For number 1, it shows was it warmer at 3 p.m. or 9 p.m. So we have to find that on the graph. So we can say, well, for this one, so kind of graph this out. So it says 3 p.m. Again, time is hours afternoon. So this is 1 p.m., 2 p.m., so on and so forth. So we can say, okay, here's my point 3 p.m. right here, and here's 9 p.m. up here. So we can say for this one that 9 p.m. is going to be the one that was warmer because the temperature was higher. The next part, it says approximately when was the temperature the highest. So if we trace along the graph, find where it's at its peak, we can say, it's about right here, which is in between 5 and 6. So we can say it's about around, we can say 5:45 p.m. And for number 3, it says find another time that the temperature was the same as it was at 4 p.m. So we have to find the temperature at 4 p.m. Hey, it's about 57 degrees, so we're going to say that we're looking at this point right here. We're saying we need another point, and what we can do is we can actually trace along and find another point where it's at that mark. We can say around, 8 p.m. So we can say 8 p.m. and 4 p.m. was about 57 degrees. Then for number 4, it says, did the temperature change more between 1 p.m. and 3 p.m. or did it change more between 3 p.m. and 5 p.m.? Well, if we look on our graph, we're talking about the segment from 1 to 3, this segment right here. So let me actually highlight that real quick. Talking about from 1 p.m. to 3 p.m. versus do orange versus 3 p.m. to 5 p.m. So even though 3 p.m. to 5 p.m. is higher, meaning it was warmer during that time, it's asking about which one increased more. So we're going to say the temperature changed about 4 degrees from 1 p.m. to 3 p.m. However, it changed about 3.5 degrees from 3 p.m. to 5 p.m. So we're going to say that it changed more. Let's do it like this. Changed more between 3 and 1 p.m. All right, on the next one, it says, does this graph show that the temperature is a function of time or time is a function of temperature? Well, always got to look at your x-axis and y-axis. So we're saying, this is our x-axis and this is our y-axis. And we're always going to say, whatever's on our y-axis is going to be that dependent variable. That's what the function is going to be. So we're saying that temperature is a function of time for this graph. So we're going to say temperature is a function of time. And it says for number 6, when the input of the function is 8, meaning at 8 p.m., what is the output? So we can say, well, if I look on the graph, I can plot out that point, and I can say at this point, 8 p.m., like we found before, it was 57 degrees. So make sure you're thinking, again, that input, it's talking about the x value. So when your x is 8, what is your y value? So make sure you can understand those words and how they apply to a graph. All right, the next part towards the bottom, it says the graph shows the amount of garbage produced in the U.S. each year between 1991 and 2013. For part A, it says, did the amount of garbage increase or decrease between 99 and 2000? So find those 2 points. So I can say, well, I'm looking at these 2 points right here because this is from 99 to 2000. So we're going to say this is going to be increase. And then for part B, it says, did the amount of garbage increase or decrease between 2005 and 2009? So find where those two are at. So I have 2005 and 2009. So between these 2 points, I can say it actually decreased. It actually decreased for that one. So then it says for part C, it has between the years 1999 and 1995, the garbage increased for 3 years, and then it decreased in the 4th year. Describe how the amount of garbage changed between the years of 95 to 2000. So we could say something like this. We could say, hey, the garbage or the amount of garbage decreased for 1 year, and then it increased 4 years in a row. So we're just kind of talking about this section here. So it's talking about from 95, where's that at? 95 to 2000. So if you look, we're talking about this section here. So it's saying it went down 1, but then it went up 4 years in a row. So just notice, again, be able to talk about the graph and be able to have statements about that very simply. On the back, it says the graph shows the percentage of garbage that was recycled between 1999 and 2013. So it says, when was it increasing? So we're saying, as our graph goes from left to right, is it going up? So we're going to say a couple spots here. We're going to say from 1991 to 2000, or sorry, from 1991 to 1996. Let me highlight that for you. It's increasing. So that's going to be from here to right here. It's increasing very easily. Again, as it's going to the right, it's going up. And then from 98 to, which is about right here, we'll say from 98 to the whole way to 2013. So that's also increasing. So notice how those highlighted lines that I have, those are, as they move to the right, they go up. And then it says, when is it decreasing now? Well, we could say from, let's put that right there, actually. Yeah, let's do that there. So it's decreasing now from 96 to 98. So where's that at? We said 1996. It's about right here to 98. And from 2011 to 2013, which is those three as well. So notice how as we move to the right, those are going down. So just be able to kind of notice those patterns when you're working on that graph. And for the last one, it says tell a story of the change in the percentage of garbage recycled in the U.S. over this time period. So got a couple things going on. We're going to say the percentage of garbage, if I can spell that right, let me fix that real quick. Need that G in there, percentage. There we go. Percentage of garbage recycled generally increased from 91 to 2011 at a peak in 2011, meaning it was at its highest in 2011 for amount recycled. And then it began to decrease from 2011 and on. So be able to read the graph and tell what is happening. All right, so underneath that, we've got some practice problems for us to do. So it says the solution to a system of equations is 6, -3. It says to choose 2 equations that might make up the system. So what I'm saying here is this. I'm basically saying which equation has the point 6, -3 on its line. So what we're going to do is we're going to graph these equations out and figure out if it's on the line, if that means it is a solution point. If it's not on the line, it's not a solution point. So let me pull up my Desmos calculator. And let me do the first one, and then I'll pause for your turn. So it's saying, okay, let's type in first. Let's type in the point that we're looking for. So we're plotting the point 6, comma, -3, which is right there. If it'll let me graph it, there you go. Let me make that a little bit more obvious. So do that. We're saying, okay, this is the point that we have to go through. So we're trying to figure out which of these equations works out. So let's try it out. So let's try that first one. It says y equals -3x plus 6. And so notice how this graph or this line is not or does not go through that point. So we know this is not a solution. So we're going to say for this one, let me unhighlight it. Let me say, hey, this one is no good. So make sure you can try to pause for your turn. So let me write that down. So let me say pause for your turn. And what I want you to do is graph each equation and see which goes through the point 6, -3. So if it doesn't go through the point, it's not good. If it does go through the point, it is good. So make sure you are choosing 2. So you want to make sure that you're choosing 2 answers or 2 equations from these options. So make sure you can pause and check with me. So let me write that down, check with me. Okay, moving on. It says a car is traveling on a small highway and is either going 55 miles per hour or 35 miles per hour as their speeds, depending on the speed limits, until it reaches its destination, which is 200 miles away. So it's kind of like you're traveling on the highway or on some back roads, maybe depending on where you're at. We're going to say let x represent the amount of time in hours that the car was going 55 miles per hour, and let y be the time in hours that the car is going 35 miles per hour. And it says an equation describing this relationship is given right here. So we're actually going to take this equation 55x plus 35y and graph it out. So let's graph it out. So let me pull up my calculator. I clear these 2 out. Make sure you're doing that first one on your end where you're trying to find that system. But we have 55x plus 35y equals 200. All right, so we have a nice little graph here, a couple things going on with it. And so now we're going to say, well, what does the first question ask? It says, if the car spends 2.5 hours going 35 miles per hour, how long does it spend going 55 miles per hour? And so what that means is, again, remember, let me highlight in blue. It said, let x represent the amount of time that it's going 55 miles per hour, and let y represent the number of hours that it's going 35 miles per hour. So we're going to have 2 different values here. So it says 2.5 hours going 35. So that means y. So for this one, we're going to say let y. So let y equal 2.5. And what you can do is you can graph out this equation. So graph this line and find solution point. So let's do that on our graph. So I'm going to pull up my calculator again. I'm going to keep in that original equation. And I say, okay, let's find out when y equals 2.5. Notice how it has an intersecting line. So it's saying, hey, at this point, this is where they intersect. And what does that mean for our graph? So that means if we spent 2.5 hours going 35 miles per hour, we went 2.045 hours going 55 miles per hour. So be able to go from your graph to your situation. So for this, we're going to say, what was our x value? We're going to say x equals 2.045 hours. Alrighty. So now it says if the car spent 3 hours going 55 miles per hour, how long did it take, or does it spend going 35 miles per hour? So now it's it's kind of flipped. We're going to say let x equal 3, and we have to find y. So we're going to say pull up our graph again, clear this out, and we said when x equals 3, we have a different equation, different point of intersection. So that means when we spent 3 hours going 55 miles per hour, that means that we have 1 hour where we went 35 miles per hour. So we're going to say for this one, for number 2, we're going to say, did the same thing. We graphed the line and found the solution point. So we're going to say for this one, we went y, we're going to say y equals 1 hour. All right. And then for the last part, it says if it spends no time going 35 miles per hour, how long does the trip take? So we can say this. We can say, hey, if it spent no time going 35 miles per hour, that just means when y equals 0, what is our solution point? So let me graph that out. Let me pull it up first. Excuse me. All right, so we clear out our equation, have our original in there, and I'm just going to say y equals 0. And that's just going to be our x-axis. So where does it hit the x-axis? Well, if we spent 3.63 hours going 55 miles per hour, we would spend no time going 35 miles per hour. So let me write that down. So we're going to say for that one, it was when y equals 0, we're going to say x equals 3.636 hours. So be able to switch from your graph to your situation and be able to see what it is doing. And on the last one, it says the graph represents an object that is shot upwards from a tower and then falls to the ground. The independent variable, again that is x, is going to be the time in seconds, and the dependent variable, meaning our y, is going to be the object's height above the ground. So let's label those again. It actually has a label for us, so we have y and we have x. So notice how those independent variables and dependent variables usually line up. So in the part A, it says how tall is the tower from which the object was shot. And another way, two other ways we can say that is saying where does, let's say where does the function start? Or we could say, same kind of idea, what is the y-intercept? So it's two ways that you can kind of have the idea with it. But we're saying, if we look on the graph, where's our y-intercept? It is going to be right there. So it hits the y-axis at that point of 0, 10. So we're going to say it's going to be 10 meters for that one. Then it says, when did the object hit the ground? Well, if we trace along again, it gets shot out, it hits an apex or a peak, and then it goes down, and it hits the ground just about 6 seconds after it was shot. So we're going to say 6 seconds after it was shot. And for the last one, it says estimate the greatest height the object reached and the time it took to reach that height. Indicate the situation on the graph. So let's find that point. You're going to be able to find where your tallest point is, and I can say, hey, it's going to be about right there. So let's say about right there. And so what's going to be that point? Well, I can say, I'll give you that point. It's going to be the point 2.9, comma 93. And what does that mean for our situation? Well, that just means it's going to be about 93 meters high. And we're going to say at at 2.9 seconds. All right, so again, make sure you can understand what that means. That we're talking, if you think about the apex of a graph, or you could say it's a very similar math word that we'll talk about in a couple years, but we're going to talk about the vertex. So very similar ideas. We're going to say that includes that maximum point. Be sure to ask questions, pause, rewind as always, and super slam that subscribe button.